Okay, so let us get started. Uh, so, in the last lecture, we were talking about various features in SQL for expressing queries. We also talked about the operations that are available for combining sets of tuples. So, we looked at union, intersect and except keywords, and these the use of these will always result in a table which has by default the which removes the duplicates by default, because the results are sets of tuples. Okay. So, if you want to actually for some reason retain the duplicates in the results, then you can actually attach a keyword called all to these operators: union, all, intersect, all and except all. So, if you attach this keyword, then you are kind of indicating that I want the duplicates to be present. Okay. So, that is one additional point that I want to convey. Now, moving on, we have a very important aspects of data, which is what is data analysis. You want to sometimes want to get some summary information or the trends in certain kind of attributes, like for example, amount of sales done or the number of units sold or things like that. So, for this we often do not want the database typically has detailed information, salary of every person, etc. So, but we want aggregation information, summarized information. What is the average salary? What is the maximum salary we are paying? What is the minimum salary we are paying? Things like that. So, we want oftentimes we want to compute these aggregates. They are called aggregates. So, how does SQL support that is the next topic that we are going to talk about. So, the following aggregate functions are kind of available in SQL. So, SQL gives you these 5 aggregate functions and they are written like this. So, this stands for as you can guess, it is average and then sum of values and count of the number of items in a particular subquery or typically even an attribute and then maximum value, the minimum value in the thing. So, the max min obviously can be applied to attributes for which they are applicable, right. So, numeric kind of attributes. So, in general these things can be applied to any column of a table, and then they are used in the select clause of SQL to kind of report those values. So, we will see how exactly we will use to use these features. Now, let me give you a little bit more about these aggregate functions. So, average can be within braces, you need to mention the attribute name, and you can optionally prefix it with this word called distinct if you want to compute the average of the distinct values in that particular column, or if you want to so depending on whether you want all values in the column or only the distinct values in the column, you can use this keyword to indicate that. So, it is an optional keyword. Where in a similar way, sum computes the sum of values in a column and count computes the number of values in a column or number of tuples in a result, and max computes the maximum value in the column A, maximum of values in the column A and the minimum of values in column A. So, these are the aggregate functions that are available. If you need any other aggregate function, then the only way is for you to kind of supply your own function and then kind of invoke that, but we will see that much later. Okay, so let us start looking at some examples involving these aggregate functions in order to clearly understand what is there. So, we let us say for this discussion, let me introduce a particular relation. Let us say we have this the GATE exam, the Graduate Aptitude Test in Engineering exam. Let us say the data about that exam in a particular year is available as a relation with this following schema. So, GATE marks, registration number is the key and then name, sex, branch, what is the, is it computer science, ECE, etc., civil engineering. So, what is the branch of engineering in which the GATE exam has been taken, and what is the city of the city of origin of that person, and what is the state of in which that city exists, and what is the marks that is obtained by this student. So, let us assume that this kind of data is available, and we will see how exactly we can make use of this to compute various items of interest. So, there can be a query like this: obtain the total number of students who have taken GATE in computer science and their average marks. Let us say we want to get that. So, the way you can express this is like this. So, you want to, you are particular about the branch computer science. So, branch, so where branch CS, from the only relation is GATE marks, and now here we are using the aggregate functions. So, count of the registration number, and we can rename that as CS total, and here is again the aggregate function being used, average of marks column as CS average. Okay. So, this is how we will express this query, and what will be the result of this? What do you expect in the result? Remember, the results of SQL queries are always tables, right. So, there will be a 2-column table with CS total and CS average as the column names and the corresponding values. So, that will be the output for the thing. So, output will be CS total, CS average and appropriate values, whatever is the values. Okay. So, it is very simple to make use of these aggregate functions. You will use them in the select clause, and then you can give new names, or if you do not give new names, it will simply put count underscore registration number here and then average underscore marks, something like that. So, the names will be automatically derived from the aggregate functions and the attribute names you have used. Okay. So, the interpretation is as usual, the where clause will be applied, and for all the tuples that satisfy the where clause, in that set of tuples we will compute these averages or whatever is asked for. In this case, count of the number of tuples and then also the average of the marks. Get the maximum, minimum and average marks obtained by students from the city of Hyderabad. So, now we do not bother about the branch, but we just want to get the maximum, minimum, average marks of students from the city of Hyderabad. So, it is very simple, similar. So, in this case I have chosen not to give any aliases, I mean the renaming. So, max, min, average marks where city equals Hyderabad. Now, you may want to actually, you may not really be interested in just all the students from Hyderabad, their max, min, average marks, but rather probably you are interested in can you give me the same information branch wise for all the for all the computer science people in Hyderabad, what is the maximum, what is the minimum, what is the average, for all the civil engineering students from Hyderabad, what is the maximum average. So, you may want to do this, this is the kind of analysis that we are talking about. We may want to partition the data into appropriate groups and then apply these aggregate functions, that is another. So, here right now we are talking about applying the aggregate function on the overall complete data that satisfies a certain condition. So, let us see now how we can actually partition the data and then apply the aggregate function, because that is also often of interest to us. In fact, it is probably more of interest to us. Okay, before we go on to that, let us look at this query which illustrates a subtle point about using this aggregates. So, get the names of students who obtained maximum marks in the branch of EC. Okay. So, we want names of students who obtained the maximum marks in the, there will be several people who have obtained the maximum. Now, an attempt like this where select name and max of marks where branch is equal to EC actually does not work. The reason is that when you are using aggregate functions, as you have seen in this previous slide, whenever you are using aggregate functions, you only mention the aggregate functions here. Projecting any other attribute actually does not make sense, right. If you, so if you say name or something like that here, and then along with all these things, whose name are you referring to? So, it does not make sense to mix the ordinary attributes with these aggregate functions. So, that is why this approach actually does not work, and it is not correct to mention any attribute name. When you are using aggregate functions, attribute names cannot be mentioned in the select class unless there are what are called grouping attributes. I will talk to you about that in a little later. So, unless there are grouping attributes, you cannot mention them here. So, this will not work. So, the correct way of expressing this query, you could think about the correct way. What do you think would be the correct way of expressing this? Get the names of students who obtained the maximum marks in branch of EC. You probably have to first get the maximum marks and then figure out who are those students who got that mark. So, this already I mentioned that aggregate functions only can be specified here. So, the correct way of specifying this query is select registration number, name, marks from this gate marks thing, where branch is EC because you are interested only in EC students, and marks of the student, marks in the tuple is equal to what is this doing? This is a subquery that is actually computing the maximum marks again in branch EC. So, the correct way of handling this is to first or in a subquery find out the maximum marks. So, which can be done easily as a select max marks from get marks where branch equal to EC. So, now you know what is that max marks, there is one value, and so in the outer you are looking for tuples whose branch is EC and the marks is equal to this maximum marks, whatever is the maximum marks that has been obtained. And if the tuple satisfies these conditions, then you can project the registration number, name, and again the marks. Of course, this marks will be the same for all the people because that is the maximum marks. So, this is how aggregate functions have to be used in queries of this kind. Now, let us move on to the issue of trying to group the attributes, group the data, sorry. So, partition the set of tuples in a relation or in a appropriate subset of the relation, I mean selected using certain conditions, into groups. Again this grouping again is based on a criteria, a certain criteria, and then compute the aggregate functions for each of these groups. So, this criteria is not very complicated criteria, all that it does is to group all the tuples on a set of attributes, and they are called the grouping attributes. So, how the grouping works is that all the tuples that have the same values for these set of attributes, the corresponding attributes are put into the same group in the group. So, let us say you have two attributes A, B, then you will examine all the tuples, and if the corresponding values of A and B are same for two tuples, the two tuples have the same A value and same B value, then they will be put into one group. Okay. And how many groups will be there? As many as there are distinct pairs of values for these attributes A, B. If the A, B together, if the A, B pair has say some 10 distinct values in the data, then there will be 10 groups, 10 partitions. So, that is how we partition the set of tuples, and then for each of these partition we will apply the whatever is specified as the aggregate function. Okay. So, now the number of tuples in the output will be equal to the number of groups that result after doing this grouping. So, the specified attribute aggregate functions are going to be computed for each of these groups, and each group contributes one tuple to the output. Now, here is an interesting thing, that these grouping attributes, the grouping attributes must necessarily be available in the select class, because they are the ones that kind of distinguish each group from the other group. Their values distinguish the group from the other groups, because all the tuples in one group have exactly the same values for these grouping attributes. So, the grouping attributes will have to be reported, and then what is the whatever appropriate aggregate function, whatever aggregate function that was requested for the group can be reported. So, the aggregate functions will be reported group wise, and each group is identified by the values of the grouping attributes. And that is why in the schema, output of the schema, we will have the grouping attributes, we need to have the grouping attributes, and then the aggregate function values. So, the result of the tuple for the group is listed along with the values of the grouping attributes for that group. Okay. So, let me illustrate this with examples. Determine the maximum of the GATE computer science marks obtained by students in each city and for all cities. Assume that 4 cities exist. Well, I am just since we do not know the data, I am giving you ahead of time that there are only 4 cities available: Hyderabad, Chennai, Mysore, Bangalore, let us say. Okay, so what does it mean now? How do we proceed here? So, we have the same GATE marks. Now, we want to group the tuples along the city value, and there are 4 distinct city values, and so all the tuples that have the same city value Hyderabad will be one group. All the tuples that have Chennai as the city value will be one group, etc. So, the 4 groups will be created. So, in this case there is only one grouping attribute city. You may actually have more grouping attributes also. Let us say I have city and sex as a grouping pair of attributes. Then what we are asking for is group the tuples as Hyderabad boys, Hyderabad girls, Chennai boys, Chennai girls, Mysore boys, Mysore girls, and like that. Okay, you get the point. So, depending on the grouping attributes that are mentioned, group the tuples such that they have the same values for those grouping attributes. So, in this case if you just mention city, the values are 4 distinct values. So, you group them by you get 4 groups. And now, what is it that we are asking for? We are asking for maximum of GATE computer science. Okay. So, the query actually now looks like this: select city, city is the grouping attribute, it must appear because this is the one that distinguishes one group from the other, and max marks as this renamed max marks, from where branch is computer science. This is the new clause that we are introducing. It is called the grouping group by clause. So, group by, it is typically followed by okay, this clause has group by and the sequence of grouping attributes. In this case there is only one grouping attribute. So, you mention only that. Okay. Okay, so, to kind of summarize what SQL provides you is a way of grouping the partitioning the data tuples, and their way of and the the allowed way of grouping attributes, the allowed way of partitioning these tuples is basically by giving a list of attribute names of those tuples. Okay. Now, the result for this would be simple, something like this, whatever values. So, so there are 4 distinct values here and 4 groups, and for each group we are projecting we are picking out the. So, this of course will be computed because all the tuples that have city value Hyderabad would be considered and their maximum will be computed, etc. Now, this will, in case you add one more grouping attribute here, same branch computer science and city and sex if you put, then city, sex, max marks will come. So, then Hyderabad male whatever is the maximum, Hyderabad female whatever is the maximum, like that the result will change. Okay. So, this is one thing that is often used, the grouping feature is often used by data analysts to figure out how the data is behaving in various subgroups. Okay. Moving on, here is another example of using grouping attributes. Grouping in the university database, for each department obtain the name, department ID and the total number of 4 credit courses offered by the department. What is the total number of 4 credit courses offered by the department? Get it for each department. Now, you can see where is the data coming from. You want department name, department ID. So, the department relation has to be used, and where is the information about 4 credits of the course, number of credits for the course, it is in the course table. So, you need to bring in course table and then check whether the course has 4 credits, and then group it by department. Okay. Here is how you can mention obtain this thing. So, select department ID name and count star. So, count star is used if you do not have to bother about which attribute to count, but basically you are counting all the counting the tuples, if counting the tuples. So, count star as total courses from the information is there from department and course, and what is the appropriate combination here? Department ID should be equal to the department number. So, department uses department ID, course uses department number to indicate as to what is the offering department for the course, and credit should be equal to 4. So, this will give you all the combinations of departments and courses in which the course is being offered by that particular department and the course has 4 credits. Now, this entire chunk of data is being grouped. How is it being grouped? It is grouped by department ID name. So, it is now all the tuples that have the same department ID and the name value, department ID name value will be put into one group, and then you apply the aggregate function. So, what is the aggregate function is simply count here. So, that is how we are finding out how many number of 4 credit courses are being offered by that particular department. Now, since you want to report name and department ID together in the output, you need to put them as grouping attributes. It is actually the same groups will result even if you just do a group by department also, department ID, because it is a key, right. But then you want to report name also, and so you will put that as a grouping attribute. So, what will be the schema for this output? Department ID name and total courses, and there will be how many tuples, as there are number of departments, which is some 13, 14. Now, after performing this grouping, is it possible to report the information or for only a subset of the groups? That is also another interesting thing to talk. You have a lot of data and you have partitioned it. Now, I am interested in only some partitions. I am not really interested in all the groups. So, for this we have a new clause called the having clause. So, the having clause will allow us to specify one more condition which the group has to satisfy in order that group to be reported in the result. Okay. So, we are one more level we are going. So, report the total enrollment in each course in the event semester of 2014. Okay, total enrollment in each course. So, we want course wise enrollment details in so and so semester, but then we are not interested in those courses that do not have a minimum of 10 students, do not bother about small kind of courses. Report to me about the enrollment of courses that have at least 10 students. Now, obviously, this condition that include only courses with minimum enrollment of 10 can only be applied after you get the aggregate function, after you get the count of the number of students in that course, right. So, after you do the grouping, then you get the value, then that value should satisfy certain condition. That is what we are querying here. So, the usual where clause will not be able to handle this, because the where clause can put conditions on the normal attributes. It cannot put conditions on this on these aggregated values, because they are not available in the data. They have to be first computed, and only then you can use them for any checking of the conditions. So, that is why we have a new clause called the having clause, and what the having clause allows you to do is to select those groups which satisfy certain condition and then report information about them. So, in that condition obviously the grouping attributes as well as these aggregate function values can be used in specifying those conditions. So, here is how it can be done. So, here is a new clause. So, let us first understand the entire query. Select course ID count of roll numbers as the enrollment total. The information is all available in the enrollment relation, where the semester is even and the year is 2014, and having selected the appropriate enrollment tuples, do a group by course ID to get the group wise course wise enrollment information, and then the count of that will be applied. So, while reporting, since there is a having clause, while reporting you report only those groups that have this specific value, count roll number is at least 10. That is what this is. So, the result of this will be course ID and enrollment for all those courses offered in even semester 2014, provided those courses have at least 10 students. Okay. Now, one has to be careful about specifying these conditions. There may be a little bit confusion about whether the condition should be specified in the where clause or the having clause, but if you understand the the flow of how the query will be evaluated, you would not have this confusion. So, if where clause and having clause are both present, how exactly this happens? So, where clause performs tests on rows and eliminate rows that are not satisfying the specified condition as usual, and this one is performed before grouping of the rows is done. Okay, this testing is done before any grouping of the rows is done. Whereas the having clause is always performed after the grouping, and it performs tests on groups and eliminates groups that are not satisfying the specified condition. And these tests can only involve the grouping attributes as well as the aggregate functions. Now, you cannot, in this test you cannot use the normal attributes, because they do not make sense. The groups do not have those attributes, right. They only have these grouping attributes and the aggregate function values. So, these tests can be specified using these. So, that is what we have done here, count of roll number. So, try out some more queries using so these are the interesting constructs, definitely very useful constructs for for analyzing data, and you typically analyze data by doing a lot of grouping and aggregation, and then get to know the trends and things like that. So, you want to find out what is the city that contributed most to the sales of cosmetic items in the last quarter. So, you want to figure out first figure out the last quarter means last 3 months, I mean whatever is the quarter definitions, and then cosmetic type of things. So, that will all come in where clause, and then you do a group by the city and then figure out what is the city, and then city wise you report, then you can figure out which city has contributed most. So, a lot of these analysis kind of queries require you to use grouping and having group by and having clauses. And they are very important kind of constructs in SQL. Now, we are kind of more or less done with the main features of SQL. So, let me just wind up with a few of these other things that we can do using SQL. You can specify, you can use strings, there are some string operators in SQL, and so you can do pattern matching using like, which is a comparison operator, and then specify patterns using. So, this like comparison operator can be used to compare an attribute with a pattern. So, and in the pattern you can also use you can use percent symbol which matches any substring. For example, if you can say Ram percent matches any string that starts with Ram, Ram Kumar, Ram Prabhu, whatever. And then the underscore character matches any single character. So, there are certain pattern matching features. So, these 3 underscores followed by Naga matches any string ending with Naga, but has exactly 3 characters before that, like Ram Naga, something like that. So, this underscore 4 underscores matches any string with exactly 4 characters. So, you can use these various functions, various all this like operator and the patterns while checking the value of an attribute, whether it is equal to something or it is like this pattern. So, here are some examples. Obtain the roll number, names of all students whose names end with Mohan or begin with Mohan, or whatever you can specify like this. So, these patterns are of course are case sensitive, and then these special characters, this percentage underscore, sometimes if you want to use them, then you need an escape character. So, so backslash is the escape character for using them within the patterns itself. Okay, so that is like operator. So, here is a feature that in some sense goes slightly away from the spirit of SQL, but nevertheless it is there. So far we have seen that we don't indicate as to which condition is a joined condition, which condition is a select condition, and things like that. All conditions are there in the where clause. So, for example, if you see get the names and names of professors working in the CSC department. So, this is how the query can be specified, and you very well know that from our background now of having studied relational algebra and all that, we know that f dot department number equals d dot department ID is actually a join condition. This is a join condition, whereas d dot name equals CSC is a selection condition. So, while it is not highly recommended, but SQL does allow you to kind of introduce explicit specification of joining in the from clause. So, select f dot name from, here is a kind of a temporary relation being created on the fly by doing a join between 2 tables with a join condition. So, professor as f join, so this is a keyword join, department as d on, this is also a keyword, and the join condition, and then you go ahead give the other conditions like. So, this is how that the same query can be alternately expressed, but we do not routinely recommend this kind of thing to be done. This feature I think is essentially required when when you want to perform other kinds of joins rather than the normal inner join. The inner join will be can be taken care of by specifying the joint conditions etc. in the where clause itself. But if you want to really do the other joins, the outer joins, then there is no appropriate way to specify that in SQL. So, the default is inner join, and one can specify outer joins like left outer join, right outer join and fill outer join like this. So, in the from clause, from R1 left outer join R2 on predicate. Okay. So, when you are doing this like left outer join, right outer join, full outer join, then there is really no alternative other than specifying it like this, unless of course you can use subqueries in order to produce this outer joins also. But it is kind of convenient to say that okay, we are interested in keeping all the attributes of the left relation, and that is the kind of joins that we are looking for. So, left outer join. And natural join can be used with any of these join types by specifying the keyword natural and then the join type, and then R1 natural join type R2, and then there is an optional keyword called using attribute list in case you want to we will consider that a little later. But what natural join basically does is considers all the common attributes between R1 and R2 and then enforces equality. So, in case you want to take a subset of these common attributes, then that can be specified using this optional using keyword, and you can specify natural join also. So, these specifying this join operation kind of explicitly goes as you can see goes against the spirit of declarative specification of queries in SQL, but the positive side is that sometimes the queries will be easier to understand. So, use this feature judiciously, do not go about using it just because it is there, do not go about kind of using it without a proper reason for using it. Okay.